For this problem, we're given points P, Q, and R in three space. P is the point 132, Q is the point -147, R is the point 0, -23. And our goal is to use the cross product to find the area of triangle PQR. Now, how do we do that? What do we recall about cross products and area? A cross product is obtained by looking at two vectors. And if we take the cross product of those two vectors, we get a vector orthogonal to both of them. Fine. But the magnitude of the cross product tells us something. The magnitude of the cross product is the area of the associated parallelogram. Now, what we have here is a triangle. So we need to think about how that's going to work. And we don't have any vectors yet, but we can certainly make some. So what I want to think about is I want to think about the vector PQ, starting at P and ending at Q. So you'll notice 132 to -147. What will that vector be? Well, what is my change in x? From 1 to -1, the x's are going down 2. From 3 to 4, the y values are going up 1. And the z values from 2 to 7 going up 5. So vector PQ is -2, 1, 5. So we're going to perceive it this way. Here's P. Here's Q. Of course, this is actually in three space. And I also want to construct a vector PR. So what is that vector? From P to R, from 1 to 0 in the x direction is going down 1. From 3 to -2 is going down 5. And from 2 to 3 is going up 1. And how can we visualize that? Let's go ahead and say that's the vector PR. So we have the vector PQ here. And we have the vector PR here. Now, what the cross product will do, it will give us a vector orthogonal to both. So we think about this standing straight up relative to this plane that PQ and PR are in. Of course, in three space, not quite exactly the same. But the magnitude of the cross product gives us the area of the parallelogram. So let's go ahead and try to draw in that parallelogram. And we'll see then that that parallelogram is really twice the area of the triangle. So if I draw in this third side of the triangle, you can see it this way. So what I want to find out next is I want to find out what is PQ cross PR. So let's remind ourselves of the process I like to do with that. We put IJK across the top. PQ is -215. And PR is -1, -5, 1. And then we have to remember across the top, our multipliers are plus, minus, plus as we expand along the top row. So what will PQ cross PR be? Well, it's plus I times his minor minus J times his minor plus K times his minor. So what will that be? As again, PQ cross PR will be a vector that is orthogonal to both PQ and PR, using this visual here on the board. So again, it's plus I times its minor minus J times its minor plus K times its minor. Now, how do we find the relative minors? Well, I is minor, cross out the row I is in and cross out the column that I is in. And you see we get 1, 5, negative 5, 1. Similarly with J, cross out the row that J is in, cross out the column that J is in. Negative 2, 5, negative 1, 1. And then with K, cross out the row that K is in, cross out the column that K is in. Negative 2, 1, negative 1, negative 5. And then we have to go ahead and do the determinants of these things. So what will that give me? Plus I times what? 1 minus negative 25. Multiply across this way first. 1 times 1 is 1. Multiply across this way. Negative 5 times 5 is negative 25. So 1 minus negative 25 is going to give me 26. Minus J times, what do we get here? Multiply this way first. Negative 2 times 1 is negative 2. Minus negative 5. Negative 2 minus negative 5 would be the same thing as negative 2 plus 5. So again, negative 2 minus negative 5. It's negative 2 plus 5, which is 3. And then finally, what do we get? We get K times negative 2 times negative 5 is 10 minus negative 1. 10 minus negative 1 is 10 plus 1, which is 11. So then what is that vector? 26i, 26 in the x direction, minus 3j, so minus 3 in the y direction, and then plus 11k, 11 in the z direction. And this vector should be orthogonal to both PQ and PR. We can quickly check. 26 times negative 2, negative 52. 1 times negative 3, negative 3, which would give me negative 55. 5 times 11, positive 55. Indeed, PQ is orthogonal to this. The dot product is 0. Checking here, negative 1 times 26, negative 26. Negative 5 times negative 3 is 15. 1 times 11 is 11. 15 and 11 is 26, minus 26 is 0. So check. I check to make sure that PQ cross PR is indeed orthogonal to both PQ and PR. But remember what our goal was. We wanted to find the area of triangle PQR. So triangle PQR is going to be half as large as the parallelogram defined by this. So if that's our strategy, what are we going to say? The area of triangle PQR is 1/2 the area of that parallelogram. And the area of that parallelogram is the magnitude of the cross product. So this will be 1/2 the magnitude of the cross product, PQ cross PR. So how do we get the magnitude of that vector? What do we remember, of course? That was our big fact, yes? V dot V is the magnitude of V squared, which of course tells me then that the magnitude of V is simply the square root of V dot V. So what I need to do is I need to do PQ cross PR dot PQ cross PR, and then take its square root to go ahead and get that. So what is that going to be? We have this vector PQ cross PR. I want to do what with that? I want to take the dot product of that with PQ cross PR. Taking the dot product with itself, sort of thinking about how the Pythagorean theorem works. So that's 26, negative 311, dotted with 26, negative 311. And what does that give me? 26 times 26, 26 squared, plus negative 3 squared, plus 11 squared. There's your a squared plus b squared plus c squared. And that gives me 806. So the magnitude of PQ cross PR is the square root of 806. But that, remember, is the area of the parallelogram. So if the area of the parallelogram is the square root of 806, what is the area of the triangle? Our goal was to get the area of triangle PQR. So finishing this, the area of triangle PQR would simply be 1/2, as we can see the triangle is 1/2 the area of the parallelogram, 1/2 of the square root of 806.